Hello, welcome to this video on loci questions. What I'm going to be looking at in this video is just a few questions, some of them from Edexcel, some of them from AQA, just to essentially show you how you might use constructions to locate a particular area on a diagram. Okay. Okay, so let's look at this first example then. It says here that a stadium is going to be built. It must be no more than 10 kilometres from town A and no more than 8 kilometres from town B. And we've got a scale drawing here, nice simple scale. So every 1 centimetre represents 2 kilometres. So if we take a look at this first one, if we do 10 divided by 2, that's going to give us 5 centimetres here. So what that's telling us that we need 5 centimetres to represent that 10 kilometres. For this one, it's 8 divided by 2, which is 4 centimetres. Now, we're being asked to shade the region where the stadium could be built. And both of these towns are being represented by these crosses here. So when you are trying to work out the radius around a point, so when you need your arcs, sometimes you might need to do a full circle. So I'm just going to look at town A first. So if I look at my ruler here, it needs to be set 5 centimetres. So sharp end at 0, and then put your pencil just there at 5. And there we can see it's lined up nicely. And then I need to put that at town A and draw my arc around town A now. Really handy, these ones that have the compass bit built in as well. I think they're much easier to use personally. So we know that the stadium's got to be somewhere within this circle based on just the first piece of information, because it can't be more than 10 kilometres from town B, so from town A, sorry. So now we need to deal with town B. So I need to reset my compass to 4 centimetres here. So we can see there it's now at 4 centimetres. So if I put that there and draw a little arc here. And there we go. Now you can see we've got these two arcs overlapping. So if we do that here, then we've got now the region where the stadium can be built. So it's got to be in this area, because everywhere in this area is less than 10 kilometres from A and less than 8 kilometres from B. Okay, next question we're looking at then, we've got a scale drawing of a garden. We've got a scale of 1 centimetre to 2 metres. And a tree is going to be planted there. So the tree must be no more than 4 metres from the patio, and it must be no more than 6 metres from the pond. Now you will notice the patio is being represented by this rectangle here. The pond is just being represented by the cross. So we're going to do the patio first. So that's got to be 2 centimetres away, because we've got this 1 centimetre to 2 metres scale here. If we do 4 divided by 2, we will get 2. Now this one's got to be a 3 centimetre distance. Now I'm going to start off first by looking at the patio. So this is probably the most straightforward one, because we're going from a nice straight edge there. We just need to measure 2 centimetres from there. Draw your line up from there. And you can see that everywhere to the left here is less than 2 centimetres from this patio. So that's the easy bit. Now we've got to do our pond. So this is where we're going to need the compass here. So we need to set that at 3 centimetres. So that goes there. So just budge that into the shot. You can see that's set at 3 centimetres. So we pop that here, then we draw an arc. So everything inside that arc is less than 3 centimeters from the pond, or in real life 6 meters. So now the tree is going to go somewhere in this little area here, because everywhere here is more than 4 meters from the patio and more than 6 meters from the pond. Okay, let's have a look at this next question then. We've got a nice easy scale again. So we've got scale drawing of a room. Every 1 centimetre on there is 2 metres. We're going to put a chair in this room. And it's quite a tricky one, this one. The chair's got to be closer to AB, so that's this side here, than BC. And it must be less than 14 metres from D. So that's this point on the shape up here. So that 14 meters, we can use that with the scale if we do 14 divided by 2. So that's telling us that's going to be 7 centimeters on this diagram. So first of all, the AB and BC, now you'll notice these two sides form an angle. So what we need to do there is essentially draw what's known as an angle bisector. So we do this like so. So just, it doesn't really matter a particular distance, but don't set it too wide. But once you've set this between your sharp point and your pencil, do not adjust. Pop the sharp point at this B here. Then we're going to draw an arc just there. It needs to go over those two intersections here. It needs to go over there. Then we need to move it to this first intersection. Draw another arc just there. And then move it here. Draw another one there. Now we need to draw a line through this. What I've essentially done there is I've cut that angle in half. So everything below that line is closer to BC. Everything above that line is closer to AB. And you can check with your protractor to make sure you've done it correctly. So if I've done this right, it should be about 45 degrees at that angle. And you can see it was always about between 44 and 45, about 44 and a half. But usually you allow 1 degree either way, 1 or 2 degrees either way on most of these sorts of questions. So the chair's got to be closer to AB. So we know the chair is going to be somewhere up here. It's going to be somewhere in this section. But this is where we bring in the other factor here, which is less than 14 meters from D. So you set your compass at 7 centimeters, just there. So there we go. I'll set that at D, just there. And then you draw a little arc from D. Now you will see that everything above this arc here is less than 14 meters from D, or 7 centimeters on the diagram. But we've only actually got this little area where this chair can go, because we've got to meet both sets of criteria there. We've got to be within 14 meters of D, but also closer to this AB. Okay. So if we look at this question then, we've got the scale of 1 centimetre representing 100 metres on here, and we've got these 3 points on a map, A, B and C. And it's talking about this point P down here. So we're saying it's 300 metres from A. So if you do 300 divided by 100, that tells you it's got to be 3 centimetres on the map. Then we've got this word equidistant from B and C. So what this essentially means is it's going to be the same distance from B and C. So we've now got to show the possible positions of P on this one. So first going to do that 300 meters from A first, I think. So if you look at our ruler out, so the compass needs to be set 3 centimeters. That's just there. So, so everything along this arc is now 300 meters exactly from A. So we've then got to draw essentially a perpendicular bisector between B and C. So if I measure that, we need to know what roughly half is. So it's about 5.5 centimeters on my printout here. So if I set that about 3 centimeters, we can leave it as it is actually, because I've already set it at 3 centimeters. Then I need to bisect, get the halfway point between these two. So if I do an arc there and an arc there, so be careful to make sure you get the right intersections here, because it's not that one. And move it here to C, and then we need, just about got that one there. We need that arc there, and then we need arc just below, just there. And I need to draw a line from there to there. So on this line, everything is halfway between B and C. So it's about 2.8, 2.7, 2.8 centimeters there, which shows me I've done it right, because that's 5.5, just under. So everything along that line is halfway between B and C. So we're trying to show possible positions of P and F there, so we can just mark a few along this line. But they've got to be within that arc there. So there's 4 possible positions there. So you don't need to show every possible position, but we know it's going to be somewhere along this line inside that arc there. Okay, could carry on up here as well, of course, until you get to about here.